LLMs help people write, learn, code, and find answers fast. Without them, many tasks would stay slow and repetitive. People have dreamed of smart machines for decades. Early attempts used rules or tiny networks and often failed on real language. In 2017, researchers invented the transformer idea. It let models focus on important words and scale up well. That change made today's LLMs possible. LLMs power chatbots, translation, content tools, and even coding helpers. They change jobs, speed work, and create new businesses. Think of an LLM as a giant library and a fast librarian. The model finds patterns in all the books to guess what words come next. Models do not read whole sentences. They chop text into tokens. Tokens can be words or parts of words. Each token gets a fingerprint, a list of numbers that shows its meaning. Similar words get nearby fingerprints. Attention lets the model look at the important words for each token. It is like focusing on a few clues in a sentence. Transformers stack many layers. Each layer reads and refines the text representation a bit more. Training means showing the model billions of words and having it guess the next word many times. This teaches patterns and style. First, the model learns general language from lots of text. Then it gets fine-tuned on specific tasks like medical notes or customer replies. When the model guesses a word, it checks if it was right. If wrong, it adjusts, little by little, until guesses get better. Parameters are like tiny knobs inside the model. Each knob changes how the model combines words. Big models have many knobs. When you ask something, the model generates one token at a time. Each new token is based on what came before. The model can pick the most likely next word or try more creative picks. Different methods change how safe or creative the reply is. Temperature is a small setting that makes the model more predictable or more creative. Low is safe, high is wild. Sometimes LLMs confidently say things that are wrong. That happens because they predict likely words, not check facts. If the model sees biased text during training, it can repeat those patterns. People and tools must watch for unfair results. Teams add rules, filters, and human checks so models are safer. It is an ongoing effort with trade-offs. Training big models needs lots of electricity and special chips. That makes them expensive and has environmental impact. Bigger models usually get better at language, but each jump in size costs more money and energy, so choices matter. Training data comes from books and the web. That raises questions about copyright, consent, and who benefits. Picture a row of readers. Each reads a note, adds a thought, and passes it on. After many passes, the note becomes richer. That is like stacked layers. You can draw where the model looks with attention maps. Bright spots show strong focus and dim spots show less focus. Be clear and specific. Give examples and ask step by step. Small changes in wording can change the answer a lot. LLMs can speed up work. Teachers, writers, and coders use them to draft and brainstorm. That shifts the work people do. The next models will mix pictures, sound, and text and try to reason better. That could make them more helpful and creative. Society must decide how these tools are used. That includes laws, company rules, and public discussion. You can try small models with tiny data on a laptop. Collect text, pick a tool, train short, and test. Start small and learn. LLMs do not truly understand like people. They spot patterns and predict text. They are strong tools, but not people. Compare a vague prompt with a clear one. The clearer prompt often gives better and more useful answers. LLMs turn text into tokens, use attention to focus, stack layers to learn, train on lots of text, and need safety checks. Try simple tutorials, play with small models, read friendly explainers, and ask curious questions. Learning by doing helps most.